Hi, and welcome back to the Math Lounge, where even if we can't figure out how to comb our hair, we can figure out how to solve all sorts of mathematical puzzles and toys. Today we're going to be looking at three-dimensional graphs and the three-dimensional coordinate system. We're going to have to work through a lot of definitions and some stuff that you may know already. Do your best to keep up and to work through this stuff with me. 3D space is, I mean, it's where we live, but we're so unused to thinking in terms of three dimensions because all of our math courses up till now have dealt with flat things. I mean, a few things like have been three-dimensional, but for the most part, we're dealing with stuff in two dimensions or even one dimension. And so we need a sort of a primer on how to think in three dimensions. Descartes, when he came up with his Cartesian coordinate system, was thinking in three dimensions, not in two dimensions, even though we think largely of the Cartesian coordinate system as being a two-dimensional system. Anyway, to locate a point on the plane, like we're used to, we need two numbers, an x and a y coordinate. To locate a point in space, we need three numbers, x, y, and z. In fact, I recently obtained a 3D printer, and it has three motors that move the various, I guess, the extruder and the various um, the platform, and they're called the X, the Y, and the Z motor. So if you've ever had 3D printing, you're familiar with this idea. Anyway, you need three points or three numbers, and that's here it's A, B, C, but it could be X, Y, Z is what it is. So here's the idea: you pick a point in space, maybe right here, and then the x-axis is going to be the one of the axes. The y-axis will be another axis, and then the z-axis will be the third direction that we're talking about. Just so that we can be talking about the same stuff, you're going to see me orient my axes in this way right here, where you have the origin, and the y-axis always goes down and to the left, the right. Sorry, I'm using my left hand. I got to remember which direction is which. Right, left. So anyway, so down into the right is the y-axis, kind of pointing out towards you, but maybe down into the left would be the x-axis, and then the z-axis points up. So just like this one here. Anyway, you can once you understand that, you can think in terms of the octants, the xy plane, the yz plane, and the xy plane. I have a model of this that I 3D printed right here. These planes. And so if this is, I'll try my best to orient this the same as what's on the screen. Man, this is harder than you would think. Okay, so there we go. Finally, I figured out how to hold it. Anyway, this right here, this floor, if you will, that's the XY plane. So you have the x-axis coming out towards you or down into the left. This is the y-axis, so that's the XY plane. This one is going to be the XZ plane. This will be the YZ plane. So that's the way we're going to name these. And now that you've got those named, up here where everything is positive, positive X, positive Y, positive Z, that's the first octant. And then moving your way around, you have first, let me think for a minute here. Yeah, first, second, third, and fourth octants. Is that right? No, I went the wrong direction. Sorry. First, second, third, and fourth. Because I'm thinking backwards from the way that you're looking at this. Okay, so 1, 2, 3, 4. And then you go to the bottom and you get 5, 6, 7, and 8. So not super important to know that, but anyway, if it ever comes up, if I talk about the first octant, that's usually where it's used, is the first octant, which is this one, where everything's positive. Okay, moving on. You can think of your room. In fact, this is the way that Descartes came up with the three-dimensional Cartesian coordinate system. He thought of his room and being able to uniquely describe points in the room based on the distance from the various walls in the room. So if you think of this particular diagram here, the wall that is called the right wall, the distance from that wall is the x-coordinate. The x-coordinate points out at you, whoops, out that direction, and so that x-coordinate is coming out of what's called the right wall in that diagram. It might be easier to think in terms of the floor. The floor is the xy plane, and so the z-coordinate is how far you are away from this floor, the xy plane. All right, well, let's go ahead and do this in terms of points. We have a point ABC, and what that means is you move A units along the x-axis, then you shift and you move B units in the same direction as the y-axis, and finally, you move upward or downward if it's negative, C units, so parallel to the z-axis. So projections, we talk about projections sometimes, and so you can imagine that if you have a point in space somewhere, and you were to look down at the floor from right above that point, that would be the projection of that point onto the floor, or in our case, onto the XY plane. So these projections, it just tells you sort of the shortest distance to the various coordinate planes would be a projection directly onto the plane. And so in this diagram, we have point Q is the projection of point P. So point P is that point up there, floating around in midair. Anyway, the projection onto the XY plane is point Q. The projection onto the, so you have to be able to read this, onto the YZ plane is R, and S is the projection onto the XZ plane. Okay, so here's a couple of examples. We want to know the projections of these points onto those planes. So let's see if I can be clever here and have my, yes, I can. So the first one, we have the point -4. So the projection onto the XY plane. Basically, when we ask for the projection onto the XY plane, we're just sort of pushing it down, getting rid of the Z coordinate. And so that would be this point. Let's see, -4, 3, 0. So basically, we've taken the -5, and we've gotten rid of it and turned it into a 0. Here's another example, projection onto the, how about the XZ plane? So in this case, we're going to flatten this in the y direction, sort of look at this so that we can see just the, so we get rid of the y coordinate, and we push this up against the xz plane. Let's just do this last one. We'll just do one of these. Let's say we project this one on the right onto the YZ plane. And you can guess what's going to happen. We're going to take that coordinate system, get rid of the x part of the coordinates. So it's 0, -2, -6 is our answer. So a few more things, just so that we're all on the same page here, or all in the same plane, if you will, is the R3, or R crossed with R crossed with R, is just what we call the three-dimensional coordinate system. So it's just real numbers in all directions. So you have real numbers in the x direction, real numbers in the y direction, and real numbers in the z direction. That's what all that notation up there means. So there, get rid of that so we aren't distracted. All right, so here's a few questions that we can answer. I guess I'm bringing it back. Here we are. So we're considering these points. I want to know which point of these is closest to the xy plane. So let's talk about these points. We have point A, and point A happens to be 1 unit from the YZ plane, because the x coordinate is literally the distance from the YZ plane, and it also is let's see, 4 4 units from the xz plane. And once again, this is because the y coordinate is literally the distance from the yz plane. So how far are you from the yz plane? And that's x is the number of units. Finally, point A happens to be 5 units from the xy plane. That's, for some reason, that's the easiest one to understand because you're thinking of the floor, and the z coordinate is literally how far above the floor you are or below. So there's A. Let me just mention B, and then we'll talk about the answers to these. For B, you are 3 units from the YZ plane. You're also 3 units from the XZ plane. Now, at first you might look at that and say, wait a minute, the Y value is -3. So wouldn't you be -3 units? Well, certainly in terms of a direction, you're 3 units below or to the left or whatever of the YZ plane or the XZ plane. But in terms of absolute distances, it doesn't matter if you're on the left or right, you're still 3 units. And then you're also 9 units. You happen to be below that, that z equals -9 for this point means that you're below the xy plane, but you're still 9 units from it. Okay, so now that we got that straight, we can just talk about C. C is 5 units from the YZ plane. It's 5 units from the XZ plane and 4 units from the XY plane. So which one is closest to the XY plane? That happens to be, so let's see, I'll number these 1, 2, and 3. There's my 3 questions. So, whoa, I almost got it wrong. Okay, so the correct answer, yes, the correct answer for, dread, I keep getting it wrong. Okay, I need to speak first and then write. So we're looking for the point that is closest to the xy plane. That's the one with the smallest z coordinate, which is letter C. So C has the smallest in absolute value. So C is the right answer for part 1. Number 2, which point is closest to the xz plane? This is the point with the smallest y value, and that happens to be point B. And then which one is closest to the y, which one are we on? YZ plane. That's the smallest x value, which happens to be point A. You've got questions about this? I know you do. Come on to class and let me know what you think so we can answer those. Okay, so we're moving on. I'm going to finish up a few more things. This one is, well, we might as well do it. Projection of B onto the XY plane. So we'll call that question 1. So when you're projecting onto the XY plane, you just get rid of the Z coordinate. It's like you're squishing down your Z coordinate. So you just take 3, -3, and then turn the Z coordinate into 0. So that's it. For number 2, we're projecting onto the C, onto the YZ plane. So that means we're squishing down the X coordinate. And so that means my X coordinate will be 0, but the other things stay the same. And that's it. Okay, so that does it for this video. In the next video, we'll take a look at some surfaces.